The room fell into a heavy silence as the unsettling news became known to everyone. Time seemed to slow down, and each person in the room felt the mounting anxiety. A mission that was supposed to be a routine flight had suddenly turned into a catastrophe, causing everyone to fear the worst. The astronauts aboard the Boeing Starliner found themselves in a deadly trap. Failures in the spacecraft's systems had made a return to Earth impossible. Each moment they spent in space increased the risk, and with every passing minute, hope dwindled. Now the entire world holds its breath, awaiting answers to the crucial question: will they find a way out of this situation before it's too late? If you're eager to uncover what happens next and stay updated on the latest space mysteries, hit the like button, subscribe, and join us for more stories that keep you on the edge of your seat. The launch and the initial stages of the orbit went smoothly. According to Time, the ISS is equipped with 6 sleeping quarters, each with sleeping bags and storage for personal items. Astronauts can use headphones to isolate themselves from noise. Upon arrival at the space station, the Starliner docked with the already attached SpaceX Crew Dragon capsule. NASA officials have stated that they want to have 2 different American spacecraft capable of ferrying astronauts to orbit. Starliner was launched with a small but persistent helium leak in a specific collector, the lines directing pressurized gas to valves controlling a specific engine. Later, flight controllers discovered signs of 2 more helium leaks in different parts of the spacecraft's pipeline and took measures to isolate the affected lines. This stopped the leak, but disabled 6 out of 28 thrusters in the control system across 4 propulsion modules on the Starliner's service module. The crew managed to restart 4 engines and manually piloted the spacecraft to a 200-meter stop point at the station. It is worth noting that NASA and Boeing had long delayed the test flight of the spacecraft due to ongoing helium leak remediation. Reports of issues with the Boeing Starliner spacecraft began several months ago. 2 astronauts, experienced Navy test pilots, were sent to the ISS on a research 10-day mission, but encountered a serious malfunction that made their return to Earth impossible. A team of NASA and Boeing engineers worked around the clock to find a solution, but the situation proved more complex than initially thought. According to NASA representatives, the spacecraft's technical issues were critical. Problems with navigation and life support systems rendered the Starliner unfit for a safe return to Earth. Engineers worked intensively for weeks to devise a rescue plan, but it was clear that resolving all the issues would require considerable time and effort. The New York Times notes that preparation for the flight spanned several years. In 2014, NASA awarded contracts to Boeing and SpaceX. Initially, Starliner and SpaceX's Crew Dragon were expected to be ready by 2017. However, both companies required more time than planned, a common occurrence in the aerospace industry. Meanwhile, the 2 astronauts aboard the ISS had to adapt to a new waiting period. They continued with their scientific tasks, but the uncertainty of their return being postponed indefinitely weighed on them. On Earth, NASA and SpaceX mission control centers engaged in active discussions on how to ensure their safe return. Musk personally took responsibility for organizing the rescue operation, and his team began developing a plan to use a SpaceX spacecraft for transporting the astronauts back to Earth. However, time passed, and the Starliner issue remained unresolved. The wait was prolonged, and patience in the Flight Control Center began to wear thin. NASA and Boeing realized their reputation was at stake, and any mistakes or delays could result in disaster. Meanwhile, Elon Musk and his SpaceX team worked actively on an evacuation plan. One key element of this plan is the Dragon spacecraft. It is equipped with automatic docking systems and the capability for manual control if necessary. The spacecraft also has life support systems capable of sustaining the crew for extended periods in an emergency situation. Will the Boeing Starliner program overcome its series of technical issues and prove its viability? On February 1, 2010, NASA supported the development of a spacecraft by Boeing, awarding the company a grant of $18 million. In August 2011, Boeing announced that the CST-100 would first go to space in 2015, in both an unmanned and manned version. In May 2014, it was announced that the first unmanned test flight of the spacecraft would occur in January 2017, with the first manned orbital flight scheduled for mid-2017. On September 16, 2014, Boeing became one of two winners of the CCTCAP competition and received a $4.2 billion contract from NASA to complete the spacecraft's development and certify it for flights to the ISS. Under the contract terms, each spacecraft's cabin must accommodate a crew of at least 4 people and 100 kilograms of cargo. Additionally, the spacecraft must be capable of staying docked to the station for 210 days to ensure the return of astronauts and cosmonauts to Earth, and if necessary, their emergency evacuation. NASA hoped that the new spacecraft would allow increasing the ISS crew to 7, providing more time for scientific research. Assembly of the spacecraft began in August 2016. Initially, the first unmanned launch was planned for June 2018 and the manned certification flight for August 2018. However, in October 2017, the schedule was changed. The unmanned launch was moved to August 2018 and the manned flight to November 2018. By March 2018, Boeing had 3 Starliner capsules, Starliner 1, 2, and 3 in production. In April 2018, unofficial sources reported that the first unmanned launch would be further delayed by 3 months to November 27, 2018. In August 2018, NASA published new target dates for the spacecraft's test flights. The unmanned launch was expected at the end of 2018 or early 2019, and the manned flight in mid-2019. By April 2019, the dates were revised. The unmanned launch was set for August 2019 and the manned flight for late 2019. These deadlines were also missed. The Boeing Starliner program, which started with grand ambitions and hopes for space exploration, has faced numerous challenges and delays, even during the design phase, which have significantly undermined the company's reputation. The first unmanned Starliner flight in December 2019 was intended as a critical milestone to demonstrate the spacecraft's reliability and safety. However, the flight ended in partial failure, casting doubt on Boeing's ability to meet its objectives. The primary issue was a software glitch that prevented Starliner from reaching the correct orbit for docking with the ISS. The problem occurred just minutes after launch. The spacecraft's automated control system miscalculated the engine burn time, causing deviation from the planned trajectory. Instead of continuing toward the ISS, Starliner began using fuel in attempts to stabilize its position. When the error was discovered, it was clear that there would not be enough fuel to complete the mission. Ultimately, the spacecraft had to abort the mission and return to Earth early. This partial failure raised serious concerns about Starliner's safety. The software glitch demonstrated that even minor coding errors could lead to catastrophic consequences. In a manned mission scenario, such an error could jeopardize astronauts' lives. These events prompted serious discussions within NASA and Boeing about the need to revise testing and software development procedures to ensure maximum reliability and safety for future flights. After the failure of the first uncrewed Starliner flight in 2019, Boeing faced the challenge of restoring confidence in its spacecraft. A second uncrewed flight was planned with the goal of demonstrating that all identified issues had been addressed and that the spacecraft was ready for crewed missions. However, the retry in 2021 proved to be as problematic as the first attempt. Before the launch of the second uncrewed flight, Boeing and NASA experts spent several months in intensive preparation, checking every element and system of the Starliner. Special attention was given to the software, which had been the cause of the initial failure. This time, everything seemed ready for flight, and expectations were high. Nevertheless, just hours before the launch, another failure occurred, this time in the propulsion system. The problem was identified with the valves in the propulsion system, which did not open as expected. This malfunction led to a last-minute cancellation of the launch, causing another wave of disappointment and criticism. These new issues raised serious concerns about the reliability of Starliner. Critics noted that the repeated incident with safety and technical problems indicated deeper systemic flaws in the design and management of the program. As a result, the launch was postponed indefinitely, adding further delays to the flight schedule and jeopardizing NASA's plans to use Starliner for transporting astronauts to the ISS. The propulsion system problems became a significant test for Boeing. The company's engineers conducted a thorough investigation to understand why the failure occurred and how to prevent it in the future. Corrosion issues in the valves were discovered, which could be related to storage conditions or materials used in the design. Addressing these issues required significant effort and time, further pushing back the flight schedule. These events had serious repercussions for the entire Starliner program. Delays and recurring technical failures began to cause dissatisfaction not only among the company's partners, but also within NASA itself. Many started to doubt Boeing's ability to successfully complete the project and ensure safe flights for astronauts. Competitors like SpaceX continued to advance their successes, which increased the pressure on Boeing. The company's leadership was forced to acknowledge the severity of the situation and take decisive action to rectify it. Additional checks and testing of all Starliner systems were conducted, quality control measures were strengthened, and external experts were brought in to assess the current state of the program. At the same time, NASA, as the primary customer, became more actively involved, requiring Boeing to provide regular updates on progress and additional verification of all systems. The situation with the second uncrewed Starliner flight in 2021 further damaged Boeing's reputation, showing that the company still faced significant technical and managerial problems. Despite all efforts to resolve the issues, delays continued to accumulate, creating additional difficulties for the program's execution. As a result, the future of Starliner remained uncertain, and Boeing faced the challenge of doing everything possible to restore confidence and prove its capability to meet the challenges. What happened next? On June 5, 2024, two American astronauts, Sunita Williams and Barry Wilmore, flew into space aboard Boeing's Starliner spacecraft, and this time, the Starliner program issues reached a critical point. The group of astronauts aboard the International Space Station, ISS, found themselves in a difficult situation, further damaging Boeing's reputation and raising new concerns about the safety and reliability of their spacecraft. These astronauts were part of a scheduled mission, and their return to Earth was supposed to be facilitated by Starliner, which was still experiencing problems and delays. When it became clear that Starliner would not be able to safely return the crew to Earth within the planned time frame, NASA and Boeing had to develop alternative plans. However, with each passing day, the situation became increasingly tense, causing anxiety not only for the astronauts, but also for their families and colleagues on Earth. At this critical moment, it became evident that Boeing needed to urgently rectify the situation and restore confidence in its project. The issues with Starliner were not only undermining the company's reputation, but also jeopardizing vital space missions, which was unacceptable given NASA's ongoing advancements in its space program. Under pressure, Boeing intensified its efforts to address the malfunctions and conduct additional tests to return Starliner to operational status as quickly as possible. Meanwhile, the crew on the ISS continued to work under heightened uncertainty. Each day of delay meant additional risks and challenges associated with an extended stay in space. The situation reached a climax when it became clear that a return to Earth could not be ensured in the coming months, and the astronauts had to resign themselves to staying in orbit much longer than initially planned. As of now, the plan is for the spacecraft to return to Earth without the astronauts, and Wilmore and Williams will remain on the ISS until February 2025. When it became clear that the Boeing Starliner would not be able to return astronauts to Earth on time, NASA was forced to seek alternative solutions to ensure the crew's safety. Given the limited resources and capabilities in orbit, time was of the essence. NASA turned to SpaceX, which, with its reliable and proven Dragon program, had already established itself as an effective means of delivering crews to the International Space Station, ISS, and returning them to Earth. However, using the Dragon capsule in this situation posed a unique challenge. Originally designed for regular flights to the ISS and crew returns, the capsule was not specifically intended for rescue missions. Nevertheless, NASA and SpaceX collaboratively developed a plan to use Dragon for rescuing astronauts stranded on the ISS due to technical issues with the Starliner. This plan included modifications and additional checks to ensure the safety of the rescue mission. With time constraints, SpaceX had to rapidly implement necessary changes to the Dragon's design and software. One of the key tasks was to ensure the capsule's safe docking with the ISS and subsequent return to Earth under potentially less favorable conditions than standard missions. Despite its lack of specific design for rescue operations, the Dragon capsule was well prepared for the task. The modular design and flexibility of the control system allowed SpaceX to quickly adapt the spacecraft to new requirements. Additional features and safety systems were added to address potential complications associated with evacuating astronauts. For example, the life support system was enhanced, and the amount of supplies was increased to ensure crew survival in the event of a longer-than-expected flight. NASA also actively participated in mission preparation, providing resources and expertise to coordinate all stages of the operation. The joint efforts of both organizations included numerous simulations and tests to ensure every aspect of the mission was meticulously planned. Special attention was given to communication between the astronauts remaining on the ISS and the flight control centers on Earth. Defects discovered in the Starliner design, as reported by Elon Musk, have caused significant criticism and cast doubt on the safety and reliability of Boeing's spacecraft. These issues have drawn attention from both experts and the general public, intensifying the pressure on the company to prove that its spacecraft can perform its missions without endangering astronauts. According to representatives from Valve Tech, the valve developer for Starliner, launching the spacecraft with existing problems was a mistake. The criticism of Boeing was swift. Engineers and experts began actively discussing the identified defects, highlighting their potential risks. The focus was primarily on the Starliner's control and navigation systems, which specialists believed could lead to improper spacecraft behavior during key maneuvers. Errors in software and design flaws in the propulsion system raised concerns that such problems could result in catastrophic outcomes in manned missions. Engineers reported a 0.77% probability that the spacecraft might fail to perform the braking maneuver at the end of the mission, potentially failing to leave Earth's orbit. These defects also questioned Boeing's ability to conduct effective checks and testing of its systems. The company's developers and partners began to question the thoroughness and reliability of the testing conducted before spacecraft launches. There was a risk that design and manufacturing shortcomings could recur in the future, jeopardizing the successful execution of space missions and overall flight safety. Public discussions and criticism also increased the pressure on NASA, which had previously relied on Starliner as a key element of its space program. Given that the space agency had already faced delays and issues with the Boeing program, the discovery of such serious defects only exacerbated the situation. NASA was forced to reassess its plans and possibly seek additional solutions to ensure the smooth operation of the International Space Program. Furthermore, the identified issues significantly impacted Boeing's reputation. The company, once renowned for its achievements, faced the threat of losing trust. Competitors, such as SpaceX, seized the opportunity to showcase their advantages and the reliability of their solutions. Space Exploration Technologies Corporation, known as SpaceX, is an American aerospace manufacturer founded in 2002 by former PayPal shareholder and Tesla CEO Elon Musk, with the goal of reducing space travel costs to pave the way for Mars colonization. As of 2022, SpaceX is the world's largest satellite operator. The company operates the Starlink program through its subsidiary to provide high-speed satellite internet globally, with over 6,000 small satellites in orbit as of April 2024. As of June 2024, SpaceX's market capitalization is approximately $200 billion. The statements about Starliner's issues emphasize that SpaceX has a more robust and proven system, strengthening their market position and providing additional opportunities for future growth. For Boeing, this crisis was a significant test. The company's management had to acknowledge that the problems with Starliner affected fundamental aspects of development and project management. In response to the criticism, Boeing was compelled to intensify its efforts to rectify defects and implement additional safety measures. Detected defects in the Starliner design and the subsequent wave of criticism only intensified skepticism and negative public perception of the program from both the public and government officials. Amid rising discontent, the demand for Boeing to correct its mistakes and restore trust became even more urgent. Government officials responsible for the US space program expressed concerns about the current state of Starliner and its future involvement in space missions. Congress members and senators began posing serious questions about how such significant defects arose and how Boeing planned to address delays and additional costs associated with resolving these issues. Discussions about potential contract revisions and even the possibility of terminating cooperation with Boeing became a reality as government bodies sought to ensure that their investments and programs were protected from potential risks. Public opinion also shifted dramatically. News about defects and shortcomings of Starliner resonated widely in the media and on social networks. Citizens observing the developments began expressing concerns about the safety of space flights and Boeing's ability to ensure the reliability of its technologies. Public debates focused on whether it was sensible to continue funding and supporting a program that had already faced numerous problems. Criticism from the public and government structures led to the necessity for Boeing to ensure complete transparency and provide convincing evidence that the company was capable of correcting errors and restoring the safety of Starliner. A series of hearings and meetings were held, during which Boeing representatives were required to explain the causes of the issues and present a plan for their resolution. These events attracted media and public attention, emphasizing the importance of a responsible approach to space projects. In response to the criticism, Boeing took several measures to improve its program. The company enhanced collaboration with NASA and other partners to work together on addressing defects and improving quality control. Additional working groups were established and external experts were brought in for independent reviews. Boeing also began developing a new plan to update the Starliner system and implement additional checks and tests to demonstrate that all identified deficiencies would be resolved. However, despite all efforts, skepticism and criticism continued to pressure the company. Many experts believed that the Starliner program was in crisis and its future was in question. Competition with other companies, such as SpaceX, exacerbated the situation, as the successes of competitors further highlighted Boeing's problems. Amid ongoing issues and criticism, the company faced deep mistrust from the public, government bodies, and partners, complicating its efforts to rehabilitate its spacecraft. An internal investigation by Boeing revealed a series of design and procedural errors, and the company took steps to address them. However, despite these efforts, the results of the investigation and the measures taken were insufficient for a full rehabilitation of the Starliner. The identified issues left a deep mark on the company's reputation, with many observers believing that defect rectification and process improvement could not fully compensate for previous mistakes. One of the key problems was that defect rectification required significant time and financial investment, which further exacerbated the situation. On July 31, 2024, Boeing announced new financial losses related to the Starliner commercial flight program. In its quarterly report, Boeing reported a loss of $125 million due to delays in conducting crewed test flights, which are still ongoing. Since the beginning of the Starliner program, the company has incurred total losses of $1.6 billion. This situation created additional challenges in restoring trust from both partners and clients. Public opinion remained negative. Issues with Starliner became the subject of extensive discussion. Even with technical improvements and efforts to enhance safety, the overall perception of the program remained in question, making it difficult to attract new customers and investors. The situation with the delay and subsequent evacuation of astronauts due to issues with the Boeing Starliner sharply highlighted the need for stringent oversight and independent verification of safety standards in the space industry. This incident served as a significant lesson for all participants in space programs, demonstrating that even minor flaws in the system can lead to serious consequences and jeopardize the lives of astronauts. In response to the crisis, many space agencies and organizations have strengthened their safety standards requirements. NASA, in particular, has reviewed its protocols and requirements for private companies working on space programs. The introduction of additional stages of verification and certification has become mandatory for all participants in space missions to ensure that all systems and components meet the highest safety standards. Moreover, independent audits and inspections have become crucial tools for ensuring transparency and reliability. The introduction of independent third parties to conduct tests and evaluate systems has become a standard practice, allowing for the avoidance of potential conflicts of interest and ensuring an objective assessment of technology conditions. These measures are aimed at preventing a recurrence of errors associated with insufficient quality control and inadequate verification. The importance of independent safety oversight has also spurred the active development of new technologies and verification methods. Experts have begun working on improving testing processes, including the use of modern simulators and computer models that can identify potential problems at early stages of development. These innovations contribute to a more thorough and reliable evaluation of systems before their use in actual missions. The Starliner crisis has also acted as a catalyst for further development of international collaboration in spaceflight safety. The exchange of experiences and best practices between various space agencies and private companies has become an important step in raising the overall level of safety in the industry. Joint efforts in developing new standards and protocols have helped create a more rigorous and effective safety control system. This incident became a catalyst for a deep analysis of how strictly private space companies should be regulated and what their obligations are for ensuring safety. One of the key issues has been whether private companies should adhere to the same safety standards as governmental agencies. In light of the Starliner issues, which demonstrated serious shortcomings in safety systems, discussions have focused on the need for unifying requirements and standards for all space mission participants, regardless of their status, private companies or governmental agencies. Many experts and regulators have begun to insist that private companies working in the space industry and performing crucial tasks such as transporting astronauts and cargo should meet the same stringent safety standards and protocols as governmental agencies like NASA or ESA. This requirement stems from the need to ensure safe and reliable flights, especially when it comes to human missions and critical tasks. Critics argue that private companies, even if they offer innovative solutions and technologies, should undergo the same levels of certification and scrutiny as governmental bodies. This includes conducting independent audits, safety inspections, and comprehensive testing of all systems. Adopting such measures is aimed at preventing errors that could jeopardize missions and astronaut safety. On the other hand, some proponents of private companies argue that the innovation and flexibility inherent in the private sector can lead to new and more effective approaches to safety. They emphasize that strict regulations could slow down technological advancements and increase costs. However, these arguments do not diminish the need for fundamental safety standards and transparency that must be ensured in any case. As a result of these discussions, measures have begun to harmonize safety standards between governmental and private players in the space industry. Space agencies and regulators have started developing new directives and rules that include mandatory requirements for private companies operating in critical areas, such as crewed space missions and cargo delivery to orbit. These rules aim to ensure that private companies adhere to high safety standards similar to those applied to governmental agencies. How then do companies involved in this program ensure compliance with safety requirements? The Commercial Crew Program, the first crewed test flight of the program, took place on May 30, 2020, on the private SpaceX Crew Dragon spacecraft. Launched by NASA to stimulate competition and innovation in the space industry, has faced significant criticism for inadequate safety oversight. This program, designed to support private companies in developing and operating crewed spacecraft, encountered issues that revealed serious shortcomings in safety management. The Commercial Crew Program was conceived as a way to encourage private companies to participate in space missions and provide alternative solutions for transporting astronauts to the International Space Station, ISS. The main goal was to promote competition and the introduction of innovative technologies that could improve the efficiency and cost of spaceflights. However, amid the problems with the Starliner program, these goals were called into question. Critics argue that in the pursuit of innovation and accelerated program development, not enough attention was paid to strict safety oversight. The Commercial Crew Program, which was initially supposed to improve the safety and reliability of space missions, was accused of having inadequate control and certification approaches. The problems encountered with Starliner showed that the inspection and certification procedures were not always adequate and did not provide the necessary level of safety for crewed missions. The Commercial Crew Program, which sought to encourage private companies and expedite their participation in space missions, failed to prevent serious mistakes that ultimately led to delays and the need to evacuate astronauts. These events demonstrated that an emphasis on innovation and competition does not always compensate for the need for strict control and safety standard checks. In response to the criticism, NASA and other regulatory bodies began to revise and strengthen their approaches to safety oversight within the Commercial Crew Program. Additional requirements and inspection procedures were introduced to ensure that private companies adhere to high safety standards. The inclusion of independent experts to assess safety and regular inspections became mandatory for all program participants. Certification processes were also updated to ensure a deeper and more comprehensive assessment of all systems and technologies used in crewed space missions. Moreover, the criticism of the Commercial Crew Program served as a stimulus for further development and improvement of safety management strategies in the space industry. Space agencies and private companies began actively working on creating stricter standards and protocols to ensure that innovations and competitive advantages are not achieved at the expense of safety. The necessity of international cooperation and clear protocols in case of emergencies was vividly highlighted in the interaction between NASA and SpaceX during the Boeing Starliner incident. According to Ars Technica, if, after all the tests, NASA concludes that the Starliner engines are not reliable enough for the return trip to Earth, astronauts will have to be rescued on another spacecraft. Currently, there is more than a 50% chance that astronauts will return to Earth not on Starliner, but in the SpaceX Dragon capsule. International cooperation in the space industry requires that all involved parties, including government agencies and private companies, have clear and agreed-upon protocols for action in emergencies. This includes not only technical aspects, such as emergency evacuation procedures, but also organizational issues, such as coordination between different agencies and ensuring effective communication. Without such protocols, complex and unpredictable situations can become a cause of serious problems and threats to safety. The future of Boeing in the space industry remains uncertain as the company faces challenging tasks of addressing technical issues and restoring trust in its Starliner spacecraft. The decline in reputation and safety issues identified during recent incidents have significantly impacted Boeing's position in the space sector, prompting the company to actively work on resolving these problems and correcting its mistakes. Elon Musk's company has already completed 5 successful flights to and from the ISS since 2020, and in 2022, it received contracts for 8 more flights and $2 billion from the US Space Agency. When it comes to the space industry, observers note that Boeing is struggling to keep up with a cohort of fast-moving startups like SpaceX. Musk's company and others are producing cheaper and smaller satellites for low Earth orbit, reducing the demand for large and expensive satellites, which are the main products of Boeing and other established companies. Boeing has focused on correcting the defects found in the design and systems of the Starliner. In addition to technical improvements, Boeing is actively working on restoring its reputation. The company is taking steps to improve the transparency of its processes and openness in communication with clients and partners. Transparency has become a key factor in efforts to regain trust, and Boeing aims to provide as much information as possible about its efforts to correct mistakes and enhance safety. Public progress reports and the results of independent reviews are expected to help demonstrate the company's commitment to high standards and restore confidence in its technologies. However, restoring trust is not only a technical challenge, but also a process that requires time and effort. Reputational losses will have long-term consequences, and the company must actively work on building a positive image. This involves not only technical achievements, but also the successful completion of future missions that will demonstrate the reliability and efficiency of Boeing's new generation of spacecraft. In the future, Boeing's prospects in the space industry will depend on its ability to overcome current challenges and demonstrate its reliability and competence in space technologies. If Boeing can meet these challenges, it will provide the company with an opportunity to maintain and even strengthen its position in the space market, despite current difficulties. The events surrounding the Boeing Starliner have clearly demonstrated how unpredictable and complex space exploration can be. The issues identified during the Starliner's test flight turned out to be much more serious than expected. Malfunctions in the control and navigation systems have trapped the astronauts on board, unable to return to Earth. This incident has been a real challenge for the space community, showing that, despite all efforts, even the most high-tech projects can encounter unforeseen problems. NASA and Boeing engineering teams have immediately started working on finding solutions and fixing the issues. The astronauts stranded on the ISS now depend on the successful completion of Starliner's restoration work or the organization of alternative missions for their return. What will happen next? Subscribe to the channel and stay tuned for updates to not miss the long-awaited return of the astronauts to Earth.